In this lesson, we will be learning about two-way frequency tables. The objective for today is to use two-way frequency tables to find marginal, joint, and conditional relative frequencies. Two-way frequency tables are a little bit different than just a traditional frequency table. Two-way frequency tables are also known as contingency tables. But for the remainder of this lesson, we'll just call them two-way frequency tables. And what a two-way frequency table is it's used to show the frequencies of data from a survey or experiment classified according to two categories. So an example of this would be Joanna sent a survey to the freshmen and sophomores asking if they were planning on attending the dance. As you can see, we have couple different things going on here. In this first row, this will be the respondents of the freshmen. So the number attending, the number not attending, and then the total number of freshman responses. In the second row, we have the number of sophomores attending, the number of sophomores not attending, and then the total number of sophomores responding. Finally, if you look at the columns going down, we can also dictate or determine how many people are attending freshmen and sophomores and how many people are not attending both freshmen and sophomores. So as you can see, just other than the traditional frequency table, we have different variables going on at the same time. So a couple more definitions for you. The joint frequencies is the ratio of the frequency table in a particular category and the total number of data values. So the joint frequencies occur here in the middle. Going back to the previous slide, the joint frequencies are the white portion in here. Then we have the marginal frequencies, which is the ratio of the sum of the joint frequency in a row or column and the total number of data values. So your marginal frequencies occur on the outside here. So again, your joint's in the middle and your marginal is out in the margins. Relative frequency is the ratio of the number of observations in a category to the total number of observations. So in this particular example, 32 freshmen are attending out of the total 150 for a combined total of 21.3%. Conditional relative frequency is the ratio of the joint frequency to the marginal frequency. Now in a two-way frequency table, there's a couple of different steps that we have to follow. So let's take a look at the problem. It says 66 freshmen responded to the survey, with 32 saying that they would be attending. Of the 84 sophomores that responded, 46 said that they would attend. Organize the data in a two-way table. So the first step that we want to do here is we want to find the value of every combination of subcategories. So one combination is freshmen and not attending. Since 32 of 66 freshmen are attending, so the number of freshmen attending said that it would be, it says of the 66, so I know that 66 total freshmen are attending. Or sorry, 66 freshmen responded to the survey, with 32 saying that they were going to attend. So 32 goes into this, and then as you can see here, 66 minus 32, these are the number of freshmen not attending. So this would be a total of 34 freshmen not attending. So then step 2 would be place every combination in the corresponding cell. Okay, so once we place all of the every possible combination, so it says of the 84 sophomores that responded, so the total number of sophomores is 84. Of the 84, it says that 46 said that they would attend. So I have 46 sophomores. And then if I take 84 minus 46, I get that a total of 38 are not attending. So again, it says find the totals of each subcategory and place them in the corresponding cell. So the total number of people attending, if I just add these together, I get that 78 people are attending. And then adding the non-attendings, add those together, I get that 72 are not attending. And then finally, your total down here is going to be adding these two categories together, which should be the same value as adding these two categories together. So 78 plus 72 is a total of 150. So step 4, find the sum of each of the marginal frequencies. These two sums should be equal. So 150 plus 150. Okay. So in this first example, it says how many students responded to the survey. So again, we've looked down in that portion. We have a total of 150 students responding. How many of the students that were surveyed are attending the dance? So it doesn't get specific here. It doesn't say freshmen or sophomores. It's just how many are attending. And that total number is 78. C says how many of the surveyed sophomores are not attending the dance. So I need to go to sophomores, not attending. So that would be 38 total sophomores that are not attending the dance. In D, what does each of the joint frequencies represent? Well, that is every viable combination of subcategories. So you see here, the joint frequencies are all in the middle here, and it's every possible combination. So going column-wise, there's 78 attending, 72 not attending, 66 of respondents are freshmen, and the other 84 are sophomores, for a total of 150. E says, what does each of the marginal frequencies represent? So in the margin is the total frequency of every subcategory. So attending, not attending, freshmen, sophomores, total. Alright, so in F here it says, Heather sent out a survey asking who was working during the holiday. Of the 50 boys who responded, so the first thing I want to do is I want to say we have a total of 50 boys that responded. 34 said yes, they were working, so I have 34 total working. To find the number not working, I take 50 minus 34 for a total of 16 boys. Of the 45 girls who responded, so I know that girls has a total of 45, 21 said no, they were not working. So I know that 21 said no. So 45 minus 21 gives me a total of 24 girls that are working. So it says create a two-way frequency table of the results. So the other results would be total number working would be 58. Total number not working would be 37. And if I add these two values together, that should be the same as adding these two values together. So 37 plus 58 gives me a total of 95. And when I add these two up, I get 95 as well. In G, it says Pamela asked if anyone would be interested in co-ed soccer team. Of the 28 boys who responded, 18 said that they would play, and 4 were undecided. So a couple of things here. Total number of boys was 28. 18 said that they would play. 4 were undecided. So if I add 18 and 4 together, I get 22. Although I had 28 respond, so that means that 6 are not playing. Of the 22 girls who responded, 6 said they did not want to play, so 6 were not playing, and 3 were undecided. 6 plus 3 is 9. If I subtract that number from 22, I get that 12 girls decided they were playing. So the total number of boys and girls that said they were playing is 30. 12 people were not playing, and 7 people were undecided. So 30 plus 12 is 42. 42 plus 7 is 49. So we made a mistake. If you caught my mistake, we said that this was a total of 39. Actually, this number here should have been 13, which makes this a 31. So 31 plus 12 would be 43, plus 7 would be a total of 50 people. In this next example, we are going to create a two-way conditional relatively frequency table. So it says Joanna wants to determine the conditional relative frequencies or probabilities given the fact that she knows the class of the respondents. So step 1, refer to the table in activity 1. A total of 66 freshmen responded and 32 said yes. Therefore, the conditional relative frequency that responded said yes, given that the respondent is a freshman, is 32 out of 66. So 32 out of 66 responded, so that's about 48%. Step 2, place every conditional relative frequency in the corresponding cell. So to save a little bit of time, I will put those in there for you. And that's what your chart should look like. So H says, given that a respondent was a sophomore, what is the probability that he or she said no? So sophomore that said no would be 45%. I, what does each of the conditional relative frequencies represent? The probability that one subcategory occurred given the knowledge that another subcategory is already known. Why do you think that the columns do not sum to 100%? So we're talking about why does 48% and 55% not equal to 100? Why does 52 and 45 not equal to 100? And the reason is that the conditional relative frequency table is organized by class. So it goes strictly by the rows. So the 100% occur for the rows. We're not going to do example K or L. So I want to look at M. So it says the managers of the staff, and assistants were given 3 options for the holiday activity: a potluck, a dinner at a restaurant, and a gift exchange. 5 of the 11 managers want a dinner. So I know that 5 out of the 11 total, so I know I have 11 total managers. 5 of them wanted a dinner, while 3 of them wanted a potluck. 3 plus 5 is 8, so that means that the other 3 wanted gifts. It says 11 of the 45 staff members, so staff members was 45, 11 of them wanted a gift exchange, while 18 wanted a dinner. So I know that 18 plus 11 is 29. If I subtract that from 45, I get a total of 16. Then it says 10 of the 32 assistants, so I had 32 total assistants. 10 of them wanted a dinner, while 8 wanted a gift exchange. 10 plus 8 is 18. Subtract that, you get 14 for the potluck. So now adding up the totals here, 16 plus 14 is 30, plus 3 is 33, 10 plus 18 is 28, plus 5 is 33, 8 plus 11 is 19, 19 plus 3 is 22, and now they should all add together in the column and in the rows. So 33 plus 33 is 66, plus 22 is 88. Then 45 plus 32 is 77, 77 plus 11 is 88. So this is your two-way frequency table. We are not going to do the second portion to that, and that will conclude the notes.